So let's do this. Thank you very much, first of all, for having me here, and thanks for staying, because there are 2 rooms, so you decided to follow me for the next 45 minutes, and I hope you won't regret it. Today, I like to talk about service-oriented architecture, but before we do the deep dive into the topic, I like to introduce myself first. So, my name is Ole Michaelis. I'm from Hamburg in Germany. I'm 26 years old, and I'm considering myself as a web nerd, user groupie, and sometimes conference speaker. If you feel I'm talking bullshit, just tweet me at CodeSars, but just the nice things. Thank you. Okay, you can find my blog at codesars.eu, and you might know me because I organized a So Coded conference in Hamburg, and I'm doing a slide sharing platform called Slider.io. This is the guy. When I did this slide, I had to laugh like 5 minutes because it looks so funny, right? Okay, I'm working with Jimdo. What's Jimdo? So Jimdo is a website builder. We want everyone to create their websites without knowing HTML, CSS, and JavaScript. I'm part of the template team now. I'm working with Jimdo for about 1.5 years. So I started at the 1st of January last year. And since then, I switched teams a lot. And now I'm part, as I mentioned, part of the template team. And there, my job role actually is called shipman, whatever that means. But in my team, we are the first team in my company who's doing a service-oriented architecture. So we are trying to move services out of our monolithic application. And I want to share that story and what I learned along the way. So this talk is called Service-Oriented Architecture for Robust Scalable Systems. But I feel like this is kind of wrong. So I had this idea of doing this talk, and I really, like, the content has stayed the same, but I really want to relabel it to distributed architectures, because people tend to have a certain picture in mind when they hear about service-oriented architecture versus microservices. I'd be really open for some discussion about that, but you could fill a whole other talk with that. Where's the difference, where not? So it's really about distributed architectures because it applies to both from my point of view. Before I joined Jimdo, I was working for an incubator. And that was in the middle of 2012. And at this incubator, my job was to bootstrap projects. So every 3 months, we had a new project, and I could bootstrap it. So I had to choose which framework we used, which programming language we are in, which database, all this kind of stuff. And this was really, really cool. It was super exciting every time we started a new project, because I had this big picture in mind of what I want to do. So when you're starting something, it's really about software architecture, right? As a good software engineer, you have this picture in mind how your software should look like, right? How your architecture should look like. Making a tons of plans, choosing the right framework, all this kind of stuff. And at the incubator, the first project we did was a mobile flea market. So the idea was that you have an app on your phone where just usual people sell their not used stuff anymore. So, and with that idea, we got ahead and choose all the stuff we want to do, and I had these plans in mind. But it was a really young project, right? So back in the days, we did it with PHP and Mongo. I learned my lessons on Mongo on that project. But it's really to write beautiful software, right? You want to write this hexagonal architecture, you want to write small classes, you want to decouple things, all this kind of stuff. But on the other hand, there's all this business pressure, right? You have to ship. And this is really controversial thing, and I had tons of discussions with my CDO back then, and we always agreed on a solution which is like in the middle, so which fits for us both. So the project went out after 6 months, so we planned 3, but this is how software works, right? We plan 3, ship in 6. That's just usual. And everything was okay, so we went over to the next project, and then somehow the incubator got bankrupt. this is a weird thing because incubators usually have a shitload of money. It was a very complicated situation, but in the end, they had to fire all the people. So I lost my job. Oh, come on. Oh, no, isn't too bad, right? Because as software engineers, we get a job like everywhere, right? People just mention on LinkedIn that you're searching for a job, and it's like recruiters bomb you with messages. So it wasn't too bad. And I ended up in Jimdo, which is pretty cool. But starting at Jimdo was a complete new experience. I came in from this incubator where we were 2 people, like the CDO and me, and then the iOS guy, so maybe 3 in tech. And at Jimdo, it's a company, it's almost 8 years old now. It has, when I joined, 150 employees, 50 engineers. So I would say the code base was grown. Do you have an idea what a grown code base looks like? So it's all very tightly coupled. It has a shitload of complexity. There was million lines of code, all in one repo, 1,000 different databases, different patterns, and all over the places. Some stuff was really like spaghetti code. Other places were like super over-engineered. So for a little example, if I want to store a picture in the Jimdo code base, it affects 16 classes. Okay. As you can think, it's like super layered and adaptable, but and at other places, it's just all in one class, and the class then has 6,000 methods, 6,000 lines. So it's really grown. But for me, it was really funny because I just 1 month before, I was at this very small team, and we did all this decisions on my own, and there wasn't someone who did decisions before me. I was the person who did the decisions. And it was like a fast forward over 7 years, and I was thinking how this mobile flea market app would look like 7 years later. Maybe it will look the same. I think it depends very much on how the business constraints looks, and but everyone would agree, I hope, that this complex architecture isn't a good thing, right? It makes you slow. For us, at Jimdo, we have this feeling that shipping features in this old system takes super, super long. We're going to ship an iOS app, and it took us 2 years to do the API layer. So all the business logic was there. We just needed a new interface, a new controller layer. It took us 2 years to do that because of the complex system. So what do we have? You have super easy startups at the one hand with super simple code and super easy and cool new solutions, and then you have this grown company thing. And I bet all of you feel you're either in the one or in the other. There is not really something in between, which is weird. It won't happen that you came into your company one day and your code base is super complex. It's a slow process. But when you're in this big monolithic thing, it's like you're stuck there. So you really should change before it's too late. But what is the right time to change? And whenever I do this talk, people tend to ask me, Ole, tell me what is the right time? And I don't know. You have to answer that for yourself. It really depends on your project, on your time, and for Jimdo, for example, we're a bootstrap company. We don't have any funding. So we really have to think twice where we spend our money. And spending money on refactoring doesn't usually get you money back. Not very fast. It's like a long-term investment. But when you're a bootstrap, making this long-term investments is hard. So to avoid that, you want to distribute the architecture. You want to have, even if you have a big grown product, you want to have these small code bases all over the place talking to each other. And that is what distributed architecture, SOA, or microservice is about. So then we could ask, what is distributed architecture, SOA? And I have a few quotes I want to share. So this one is from Werner Vogel, the CEO of Amazon. And he says, service orientation means encapsulating data with a business logic that operates on that data with the only access through a published service interface. And if your goal for this talk was to learn what SOA is, you're going to go now. I think that's it. This is like, for me, the one perfect description of what SOA means. But we still have like 40 minutes to fill, so I prepared some more stuff. This is Jeff Bezos. You might know him because last year he bought the Washington Post, and he's the CEO of Amazon, and he's called to be an asshole. I never met him, so maybe it's unfair to say it. But what we can say is that he's a really successful person because he's CEO of Amazon, and he like did it all on his own, feel like 100 years ago, but he bootstrapped it. So he's the CEO of Amazon. And back in the day, in 2006, he wrote an essay or an email to all Amazon tech employees. So imagine, you're coming to work on a Monday morning, open up your inbox, and then you find this essay from your CEO, and it says, all teams will henceforth expose their data and functionality through service interfaces. Teams must communicate with each other through these interfaces. There will be no other form of inter-process communication allowed. No direct linking, no direct reads of other teams' data store, no shared memory model, no backdoors whatsoever. The only communication allowed is via service interface calls over the network. It doesn't matter which technology they use, and all service interfaces, without exception, must be designed from the ground up to be externalizable. That is to say, the team must plan and design to be able to expose the interface to developers in the outside world. No exceptions. And that wasn't it. He closed the mandate with, everyone who does not follow this will be fired. Thank you. Have a nice day. Okay. That's a tough statement, right? How will you react if you get such an email? Frankly, I would quit. I don't want anyone to talk with me like that, but that's a very personal thing. I think back in that day, it would be a good idea to stick with Amazon. But let's think of it. What happened since then with Amazon, since 2006? They got the leader in cloud platforms. They got the leader in scalable systems. And whenever we are talking about distributed architecture, Amazon is like the one referencing point. So they were pretty successful. So this email is meant to be the starting point of AWS. If you're checking the documentation on the internet, that's not true completely because the first implementation and the first steps were done in 2003. But this was like the kickoff, so to say. So pretty cool. And I got one last quote, which is called Conway's Law. It says, organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. So when we're thinking about that, it means how you communicate to your coworkers is how your code would look like. Does it also apply to your code base? It definitely applied to what Jimdo is. But Jimdo did a very special thing there. You could inverse Conway's Law. So you could just design your communication structure on how you want your code base to look like. And this is what we did. Two years ago, the Jimdo development team decided to split up into feature teams. So there was this 30-people development team doing the monoliths, right? So one team, one big code blob. And then they decided to do the inverse Conway's Law. It was by accident. It wasn't, they said, okay, we know Conway's Law, so we just inverse it. But it just worked like that. So they split it up. So we have 8 feature teams right now. So we have shop team, payment team, template team, feature team, these different kind of things. And now, 2 years later, we see that the first services are born out of this. Because as a team, we want to maintain our own code base. We do not want to share our code base with all the other teams because it really adds a lot of complexity. And there are even more reasons why SOA is good, and SOA is a cool thing. First, you can make faster decisions. So when you lower the number of people per code base, you can make faster decisions. Have you ever tried to make a technology decisions with 50 people? I did. And it's not decided yet. It takes forever. And that's just how it is, right? Because if you have a team of 3, it's already hard to agree on a database or logging framework, right? So you get like 10 people and 12 opinions. How should you ever do this with 50 people? So you get way faster if you have less people per team. For the image, it's a bit inappropriate, but I did this talk, I did this slide like a year ago almost, and this is how they did democracy in Ukraine. Anyway, so you could also unload responsibilities. And what that means is, when you have different teams being responsible for a smaller part, they're only responsible for that part. For example, I'm part of the template team. So we are responsible for everything template related. And I don't know how you feel about payments in general, but I hate payments. I mean, I know they're necessary because they give me my paycheck in the end, but I don't want to deal with all the technology in there, right? Every payment API provider sucks, besides Stripe I heard, but never did. So this is cool. I don't have to deal with APIs and domain knowledge I do not want to do. I'm just responsible for all this template stuff, and this is the domain knowledge I like. You also reduce complexity. And with reducing complexity, you have easier onboarding. And with easier onboarding and reduced complexity, you get faster development speed. And with faster development speed, you might get even happier customers, happier product managers, and like everyone is happier then, right? So this picture, this is crazy. It seems to be a really tough problem for like presidents. You see, right? This is a white phone, this is a black phone. And it's like, I don't know. It seems to be hard using this technology thing. Maybe they're just used to like cell phone, whatever. So you also get happier developers, right? Because when you have a smaller code base, you can do more deployments. You have a faster continuous integration. You have faster deployments. You can do your own technology decision. It's like, I don't see a reason why not to do it when it comes to fact I like to call it developer happiness, right? Because with a smaller code base, everything is better because it feels more like a startup. And maybe it's because I feel like I'm a very startup person, but I like the small code base. It's way more than the big monolithic ones. You can also win at scaling, right? Because you can scale each part of the system independently. So when you have the payment and the template thing, for example, if my payment is the bottleneck, I can scale up payment without touching template. If template is the bottleneck, vice versa. So you don't have to scale a monolith, which is usually pretty hard. So now your next question is hopefully, okay, Ole, this sounds pretty cool, but how can I implement it? And I got the answer. So I don't get the answer. This is maybe too much, but I can share all the lessons we learned along the way. So the first lesson is that you should build up your platform. And the first thing on building up a good platform is to get rid of every state in your application. Your application should be stateless. The most services you write should be stateless. There is some state, and I know it, and there has to be some state, but try to put the state away of most parts of applications and just make the one stateful application or separated ones, but don't distribute all the state over all your systems. Try to keep the most part stateless and just do at very specific points state, because state makes scaling almost not impossible, but really, really hard. Scaling state is really, really hard. I got a cool Jindu story on state. So back in 2008, one of my coworkers was at a conference like this one, and he heard about SQLite. You all know SQLite, right? SQLite is this super cool database contained in a file, super easy to manage, blah, blah, blah. So he had the idea that every of our customers could have their own database with SQLite. So back next day after the conference, he went to our product and implemented it. So every customer had to store their navigation, for example, in their page and their comments in their blog in a SQLite file on the server. So what does it mean? This means that every request from this customer has to go to this certain server. Because you cannot distribute this file, really, right? I mean, there are things like shared file systems, but I don't know if you ever deal with it, but you don't want to do this, really. It just sucks. So what happens is, when this server is down, we're partly down, because some customers cannot access the website anymore. So this is pretty bad, and this SQLite thing has been in our code base for about 5 years. And just last year, when I joined the company, we got rid of it, and it took us like half a year. So it took him 2 days to implement it, and we needed half a year to get it out. So really think when you have to deal with kind of state and where to put it, because it makes scaling really, really hard. You should also build up confidence. When you have a services or a distributed architecture, how you deal with authentication. Do you need authentication? Do you do everything in a VPN? Then you might not need authentication, but VPN makes it. I always feel VPN is a bad idea, because it's not accessible from the outside world, and then you have to equip people with VPN clients on their laptops, and it's all shitty. But then you need some other authentication, right? You might need some basic out, or if you're really cool, you can do OAuth. When you do HTTP-based authentication, please always use HTTPS and SSL. Super important. You should design for independence and isolation. So that relates back to the quote we had at the beginning. You should be able to found a company out of your component. It's like the Amazon idea, right? A service must not depend on other components. It's okay when it depends to other services, but not on like shared components. You should also create reliability. That means you should have automatization, right? So you can have fast recovery. This also might mean you want to use kind of a cloud or service provider. So you do not want to host your application in a database where you are responsible for changing hard disks, unless that's your core business. Because changing hard disks usually takes a lot of time and a lot of money, and other people can do this way better, like Heroku, AWS, all this kind of stuff. That means you could focus on your business goals and your business services. You should have a thing like single responsibility. When we're talking about code, single responsibility means a class should only have one single responsibility. When we are talking about services, I think this is not the exact same size or scale, because on a service level, you won't need a user updater, user creator, and user fetcher, all this kind of stuff. This is not necessary. But whenever you find yourself creating a manager class, like a user manager, this is a good, thank you very much. This is a good point to implement a service, right? You could have a user service on that. A circuit, who of you have heard of the circuit breaker pattern before? Okay, 1, 2, 3, 5 almost. So circuit breaker means that when there's one service struggling in your infrastructure, what happens if there's even more requests going on that service, right? How should one service ever recover when there's even more requests coming in? So circuit breaker is a pattern which says that which you apply on the network boundary. So on the network boundary, you have the circuit breaker, and when the circuit breaker sees that there's a request coming in way too slow, or a request returns an error, it would just prevent the next request and just return the same error code. Because you would get this error code anyway, and you give the other service time to recover. So you should not hammer more expensive requests to a struggling service. There are some pre-built implementations of that. So Netflix built a very famous one, which is called Hystrix, which runs on the JVM. And Yammer built one for JavaScript called Circuit Breaker JS. Similar to that is a pattern called backpressure. And circuit breaker is basically an implementation of backpressure, because it means when there's a service struggling, you should not pass an error through your whole system, but you should handle it on this where it occurs. So when you have the circuit breaker in place, you could not send a request to this broken system, so you have to deal with that situation. Your service has to deal with this situation. It could mean that you can just throw this request away. Imagine we are in a metric system, right? So you want to measure metrics. You could easily throw it away. You don't have to handle it because the handling would be like overload. But if you're in a payment system, for example, you do not want to throw it away, right? So it really depends on the domain here, and your domain decides how to handle this error. Another important thing is timeouts. I got a cool story on that too. So a friend of mine, he's working for Travis CI. You all might know Travis CI, right? So it's a continuous integration platform. So they pre-check your pull requests if they could be merged with the test still be green. And in order to do that, they must know if a commit can be merged without conflicts. And GitHub has an API for that. So they have the one worker doing very simple stuff. It just checks the API, and if it's mergeable, it reports back. What happened one day is that GitHub, without any further notice, changed the API. So the worker was trying to fetch the status, but didn't get a response. And the timeout was set to 10 minutes. So what's happening? Pretty easy, right? It tried it for 10 minutes, so the worker is waiting for 10 minutes. There was just one worker, so the queue was filling up, and within 2 hours, the queue blew up because it was overfilled. So just set reasonable timeouts. That's a really important thing. If you're in a distributed world, set reasonable timeouts. 10 minutes could be a reasonable timeout. I think it mostly isn't, but you really should think of what is a reasonable timeout. For usual HTTP requests, 2 seconds is usually fine. 1 second, depending on your SLA. That's okay. There's a saying that people usually can just remember 3 things out of a talk. So I want you to be timeouts is one thing, because it's really important. So now you have your platform. Now we should talk about how you can integrate them. So first of all, you can do high-level protocols, right? You can do Thrift, XML RPC, protobuf, SOAP, all this kind of things. It's okay to use that. I'm not a big fan of it, but it's really a thing you should check. It always depends on your use case. A coworker of mine just said, if you do internal services, protobuf and Thrift are a cool thing. If you do external services, HTTP is a cool thing. You can also use message queues like RabbitMQ, SQS, Zookeeper, because they are really reliable. And they are mostly really fast and easy to manage, unless you pick one of the Java queues. So here's a visualization how this could look like. So you have your service putting a job into a queue, and another service getting the queue out, the job out of the queue. Pretty basic. My favorite API or interface is HTTP API. And when we're talking about HTTP APIs, it's really important that you know the protocol, know about accept headers and content types. I just had it once, and I was really complaining pretty hard on Twitter. I was sending an HTTP request over the wire with an accept header, application JSON. What did I get back? Application HTML, or text HTML. What the fuck? Just, I don't know, give me an error that you do not support it, but don't send me any HTML back. This is just crap. So know about it, and whenever you're going to implement it, think of these use cases and do it right in your use case. An anti-pattern, most frameworks do, Rails do this as well, is you have a resource and then you append .json. This is totally against every HTTP violation, right? Your URI should mention a resource. And then when you want to have a certain format of your resource, you're sending an accept header and not a file ending. There is no file ending in resources. But that's, again, a different thing. Headers is another good example. So if you're missing a header, don't implement it in the payload. If it's a use case for headers, go ahead and implement it with the X-headers. That's pretty cool. And you can take HTTP and REST to really high level with the HSOS hypermedia thing. But I don't want to advocate any particular level. Just do whatever makes sense, but try to stick to one level if you choose one. So talking about the takeaways, after timeouts, HTTP is really, like, for me, the next takeaway. So you have your platform and your interface. And now we should talk about how do they integrate. I mean, we have defined how they communicate, how they can communicate, and where should they host it and how should they host it. But you have the services and they should form one united product, right? You want to ship a thing which looks like you have one product, not several. So the first, most obvious thing, and I would bet this is what you had in mind, is integration in the back end. So every team does their services, does their APIs, and when you need a particular information, you just go ahead, query their service, and then implement it in your response to your user. This is okay. There's also a thing which I like to call integrate on the protocol. There is obviously no integration on the protocol, but there's this thing called Xlink. Who of you have heard of Xlink? Yeah, I didn't hear of it before as well. Who of you has heard about edge side includes? Okay, edge side includes is a feature based on Xlink. Xlink is a standard. Edge side includes is a bit different, but it has well support. So here you see an example. Here in line 10, you see this edge side include tag pointing to a resource, right? So when an Xlink or edge side include supportive HTTP layer, for example, your CDN or your web server sees such an HTML response, it would go ahead and fetch the content which is here and just put it together and then deliver it. So varnish is this thing which is used the most of this edge side include feature. The next point where you can integrate is the front end. You might know Yammer, which is like a Facebook thing for companies. This is like what I know the most well-known example. Another example you can think of is this comment thing you use in your blog systems, right? So in Yammer, it's when you load that page, you get a grid. It's like an empty grid, and you get tons of loading spinners, and then your content starts to show up, one after another. And for Yammer and platforms who host your company data, this might be okay, but think that this integration on JavaScript is not indexable by search engines. Again, for companies hosting your company's secret data, this is a good thing and doesn't matter. But when it's like a blog, for example, you do not want to load blog articles in the front end with JavaScript. We have some time, so I take my time to drink here. Sip. So all this distributed architecture thing is not only about coding and platforms, integrations, tech stuff. It's also really about humans. So splitting the team, this is what we did at Jimdo, doesn't mean that the components split. We just had this 2 years where we have different teams all working on the same code base. Our deploy pipeline, the default status is red. So our continuous integration system has like a default to red, not to green. This is just, it has two side effects. So the one side effect is that people get so annoyed of the broken deploy pipeline that they want to move their stuff out of the monolithic system. But if you have to implement something, it's super annoying. So if we estimate a feature, it's like you estimate how long it would take, say 2 days, and then you add a day for deployment, just because the deploy pipeline is red. This is, I think, often relates to the part that the communication is harder when you're not anymore in the same team, in the same room, sharing the meetings. You really add boundaries when you split out teams. And when everyone can decide how they solve it, be aware that you can duplicate work. Think of REST clients. How many REST client implementations do you know? Thousands, right? You can have similar problems in your company. If you want to solve a certain problem and you're not on one team and your communication is not really well, it can happen that you duplicate work, especially the more common work in your domain. And communication is important. That's a really important point. So when you split out teams and you divide your monolithic app into smaller teams, be aware that you should not stop communicating. So I told you lots of cool things about SOA, right? But I also want to mention the downtime, the downsides of that. Downtime is one. So the first thing is logging and monitoring in a distributed world is really hard, because when everyone can decide how they solve a certain problem, like logging and monitoring, you can easily end up that every team has their own logging infrastructure, logging to a certain place and doing the alerting on how they want to do it. And then when you want to debug a thing, you have to follow a request through 3 different monitoring services and 5 different logging platforms. This is really annoying. So logging and monitoring is, from my experience, a thing you should just have once, and you should agree company-wide on the thing and then ship your logs to that particular thing. And another thing is, when the shit hits the fan and it's getting worse and you have failures, it gets really dirty. Really. So if you have cascading failures and one systems fail and they're not really resilient, the failure cascade, and it could end up in a really complex thing and really hard to recover state. Imagine you have a cascading failure, multiple systems are down. Which service you want to spin up the first without getting destroyed again because of the other services are still alive, right? If you boot up the service which has no dependent services at the first time, then you boot up the dependent one, the new service would completely shut off the already booted, and it's really complicated. And on distributed systems, or computer systems in general, the question is not if it will fail, the question is when it will fail, right? And regarding the slide, I have one personal tip. When you search for a picture, shit hits the fan. Don't. I ended up with a little kid throwing Snickers into a fan. I hope it was Snickers. At least there were nuts in it. Anyway, so the last downside I want to mention is responsibility. And don't get me wrong, having responsibility is not a downside. It's a good thing. But people tend to forget about it, because real responsibility often is an implicit thing, it's not explicit. And if you're doing distributed architecture, keep in mind that your team is responsible for the service it offers, no one else. So if you have other people in your company depending on your service, be aware that if you fail, they might fail as well, and it's your fault. Don't feel depressed now. It's not too bad. And a thing you really should try to achieve is building resilient systems, which means if a system fails, it doesn't get too bad, right? A cool story Netflix usually shares. I mean, Netflix has a distributed system of 700 services, 800 services, and they say when there's a certain part of the system not working, the user usually just don't see it, because there's a really small thing on the front side, it's just not there, and you might not miss it. So this is a really resilient system. So for the last part, I prepared some real-world examples. How is distributed architecture implemented in the wild? So I always feel like this is pretty interesting. So here you see a picture Yammer shared at last year's JSConf. I know it might be hard to read what's in the bubbles here, but that's totally fine, and it's not really important. A few things I want to point out here. You see here in the lower left corner, there's a service called Vario, and it's not dependent to any other service at all. Unfortunately, they didn't explain the image very well at this conference, but I would be super curious what this service does. Here you see there's a legend, and it says for this color, it says external service, whatever that means. And then there's another thing I want to point out. You see this service here? It's called workfeed. So in Yammer, the workfeed is something like in Facebook, your news stream, right? This thing in the middle. So it totally makes sense that everything is depending on that, right? But I do not want to be the person who's responsible for that. Oh my God. This is a lot of responsibility, and I really hope for them they build the systems resilient. In summary, on this map, and remember, it's over a year old already, they have 33 services. Another picture I have, this is from Twitter. And there's a talk by Jeremy Cloud, awesome name, Cloud. It's called Decomposing Twitter. So if you're really curious on they do it, go and watch this talk. This talk is amazing. So this is how Twitter started, right? They had their Rails application. They call it Monorail. How lovely. So they have this Monorail, and the storage is MySQL. And they figured out it doesn't scale, or wonder. So this guy who was giving this talk explained how they achieved on splitting this Rails application into smaller pieces. They switched for the JVM is one of his points. I don't want to judge about this, but in the end, this was the result. So this is pretty cool. So they really split it up, all their services, and this is just the part this guy Jeremy is responsible for. So over 20 services, excluding the monorail, for the application layer. So for everything else like advertisement, big data and all this stuff, there are even more services. What I want to point out here is that they did not get rid of this, what they call monorail. I think this will also happen to Jimdo. So however effort you put in, it's really, really hard to get rid of your old system completely, but you can really, really reduce its size and its impact on your general system. The last example I have is the Jimdo example. I hope you can still read it. So what you see here, the big blue thing we lovely call blob. So this is our blob. And when I first gave this talk, it was in February this year, it looked like this. So we have this template service, which is a service of the team I'm working. This one is a bit older. It's not really a service, it's more like a routing layer. So it was responsible for routing the request from the iPhone app to the corresponding CMS server because, you know, the SQLite database. It was there. So that was in February, and we had the first services slowly popping out of it. And then I gave this talk more often and I updated the slides. So this is how it looked like in July. So my team even managed to split the template service into the template service and the design proxy, because the template service is the Rails application, which is already 3 years old, and it also feels a bit blobby already. So we also wanted to split it. So we split it out this design proxy. But also other teams started to get their services out. For example, the payment team started. We're trying to extract the website delivering layer out of our application. And also the shop team started to refactor services out. And this is how it looks like yesterday. I just updated it at the airport. So my team again splitted another service out of it. We got things I'm not allowed to talk about. And we have the CMS part also trying to extract out of the monolithic thing. So the monolithic thing is getting smaller and smaller, which is really cool and feels pretty right for me. And I'm super proud because the first image I showed you is not even a year old. It's almost half a year. So now we are gaining more and more speed in splitting out things of our architecture. And the good thing is, every team can decide on how they manage to design the services. So for example, the design team, all these services are based in the Ruby world. This is why I'm working there and I'm doing Ruby. So they are mostly, so this one is written in PHP and they do whatever they feel right. This is a Python thing. They are trying HHVM and they do, I don't know, whatever they do. But this is cool, so they can just do what they want. I don't have to care because I know it's working. And if I need some information regarding payment, I have a public API I can query, and I do not have to look into their classes, what they're doing, and how to use it, because there's an API, a documented API. So this feels really right. And to close this, I want to summarize a bit. So SOA has some bad parts, like you might lose scale effects, and when the shit hits the fan, it could be a bit complicated, but there's always a way out of that. But there's even more, from my perspective, good parts. So you can scale each system independently. You get a smaller code base, you get faster decisions, which makes happier developers, which makes happier product management, which makes happier, faster development speed, which all in the end makes happier customers. That's it. Thank you very much. Thank you. I was talking about the 3 things you should remember, right? Do you remember them? Timeouts? HTTP, correct. Was there more? I missed one. I didn't really miss one, because the last one I want you to remember is distributed architecture. So please take this home, take this into your company, and split up your code. Thank you very much. And if you got questions, just come and find me. I think we are already at the end of time, so just find me around today. I'm happy to answer all the questions regarding Jim Loop or Slider. Thank you.